homework. I have the wrong sheet.
Yeah, we got a lot of homework.
Definitely 11, 13, 15, 16.
What's number 1 on your homework say? Oh, good. I'm going to have to pull it up on here. Is that it? Okay, which one? 6. 2/3. 2/3 log. Googly moogly. Okay. Exponents first. So this is a condensed problem, right? I can't even think because I'm so hot. All right, comes around, right? So I have log base 2 of 27 to the 2/3 plus log base 2 of 4 to the 5/2. Now remember what that denominator in that fraction means? That's the root that I'm taking of that number. So what's the third root of 27? In other words, what number times itself 3 times gives you 27? It's 3. So 27 to the 2/3 would be 3 to the second, but simplifies to 9. I think that's why y'all were going to. I was just going step by step. That's okay. Plus, what's the second root of 4? 2. And 2 to the 5th is 32. This number on the bottom tells you what you're looking for multiplied that many times. So I'm looking for something multiplied 3 times. That gives me 27. I'm looking for something multiplied twice. That gives me 4. And then you do the top, the exponent. Or it's the cubed root of 27 squared. The what? After you find the root, then you do the top exponent. Yes, yes. Because 4 to the 5/2 is the square root of 4 to the 5th, which is 2 to the 5th, which is 32. And, what? 2 to the 5th.
Just type it in your calculator.
Yeah, if you put 4 raised to the 5.
Which works unless you're on one that it's not an exact value and you have to leave it in simplified form. Make sure you understand what it is. This one, so if I had, let's say this was 16 to the 5/2. Well, that one's going to work too. Let's say it was 32 to the 5/2, right? That's the square root of 32 to the 5th power. 32 doesn't have a perfect square. So what I'd really have to do is break this down. 16 and 2. I still got this power of 5 out here, right? 4 root 2, but this power of 5 is still out here. So it'd be 4 to the 5th square root of 2 to the 5th. You could and then simplify it. You could. If you know what to divide it by, yes. So what's 32 to the 5th? Put it on your calculator. What's 32 to the 5th? What the hell? 3, 3, 5. So the point that I'm getting to is, yes, I could do that, but now I need to start simplifying it. Because I need to see if there's a perfect square I can divide it by to simplify that radical. So what I'm getting at is if you raise this to the 5th first, you've got a huge number that you're going to have to work with to try to simplify this radical down. And eventually, you will get to this. You see what I'm saying? So maybe it is easier in some situations, but others not as much. Yeah. What, Carter? You raise the 4 to the 5. 4 times 4 times 4 times 4 times 4. I would probably be okay with you being there. Do you understand what I'm saying, though, that it's not that you need to understand the way these exponents work instead of just saying I plug that in my calculator? Okay. I'm still not done with this because this is a condensed problem. So now because I am adding in the middle, that means I multiply, right? And I get log was 32 times 9. 288. That's right. She was not very impressed with James correcting her. Huh? They said you could plug what in your calculator? It's not. Go ahead, Mac. Take it. Yes. Did you put a parenthesis around 5 divided by 2? Lucy, would you tell me what Thank you. I'm going to work inside parentheses first because parentheses come first in order of operations. Yes? Divide it. How do you know you're dividing? Because it's subtraction. So I have 1/2 log base 6 k to the 9th over k to the 3rd. This is now a properties of exponents. What do you do with the exponents here? Subtract. 9 minus 6 is, 9 minus 3 is 6. Now 1/2, and what does that mean? That's right. I have log base 6 of k to the 6th, but now I'm raising it to 1/2. Whenever I do a power to a power, I multiply, so I have log base 6 of k to the 3rd. Good. I can. You got me, Lucy? Okay. Is that it? All right. Exponents first. So I have log 4x plus log x minus 3 squared. Good? Adding means to do what? Multiply. So I'm going to have log of 4x times x minus 3 squared. Unless I tell you to simplify it, well, expand it. What did you do? What did you do? Did you multiply it out, FOIL it out, and then distribute? It's a lot of work. I would have stopped right there. If you did multiply it out, x minus 3 squared would be x squared minus 6x plus 9, and then you need to take a 4x to everybody. So 4x cubed minus 24x squared plus 36x, and that's what would be just the log. 4x cubed minus 24x squared. Either or, I'm okay with you stopping there though. I'm not really testing your knowledge of FOILing here. Say again? 9. Base 3? Is that where the exponent is, or is it on the outside of the parentheses? Okay. All right, I'm going to handle these first. I have log base 3 of, and if I have an exponent of 1/2, what does that really mean? It means a square root. That's right. I might even do this. Plus log base 3 of, this is, remember when we did exponent properties and I told you there was different ways that you could do each one, and some of you might have one thing and others another. This is kind of the same thing. We could put this all under a square root here and raise all to the 3 if we wanted to. We could leave it like that. We could take the 3/2 to both of these pieces here. It just depends on how you want to simplify. I'm going to write this way. Since I chose to go with the radical here, I'm going to choose to go with the radical here. Because adding means to be what? Multiply. So I got log base 3 of, and since they're both under the same root radical, they're both square roots, I can put them under the same one. 4x cubed. And this one's kind of easy to clean up. 4 to the third is 64. What's 9 times 64? 40 minus 64. No. Oh my goodness. Times 9. 576. 576. I've got 9 x's and one more x to the 10th. Is 576 a perfect square? Is it? Yes. Log base 3 of 24 times the square root of x to the 10th. What's the square root of x to the 10th? You could have went a whole other way with this. There are about 20 different ways you could have gone with this problem, and none of them are wrong. Did you come back to 24x to the 5th? Yeah. That's the problem with higher level math. You get to a point, and then there's all these different ways you can get down to. I know. I'm sorry. I can show you my thought process through them, but you might have a different one, and that it's not that that's wrong. Okay, well, it could be wrong. That doesn't mean that it's wrong. Gosh, Carter, I thought you were opening the door. Oh, I'm talking about how hot it is. I thought Carter was opening the door. All right. What else? What else on your homework? 20. I'm going to print this out so Lucy doesn't have to keep.
The math was really hard. I don't know how to. I didn't know how to.
Because I don't. Number 20. Natural log of u cubed minus 8. It's hot.
It was so like air.
All right, so this is an expand, and since it's there's nothing that I can expand, I need to see if I can factor it at all. And this is a difference of 2 cubes. This is number 20. So I can do little parenthesis, big parenthesis, same change plus u and 2, u squared, 2u and 4. Yep. So now I can expand with addition here. Ooh. Where did that go? What? What? So now, this is number 20. This is called expanding a logarithm. Missed what? This is still homework.
Yeah, what was the second step? How do you do that?
This is a difference of 2 cubes.
Yeah.
Same change plus. Squared together squared. Yes. Square the first one, square the last one, and put them together, right. It's the signs are always same change plus. It doesn't matter about.
I understand.
Yeah, the size are same size.
Y'all are getting held up on the algebra 2 stuff. Sum of 2 cubes. This is a special pattern to factoring. Every sum or difference of 2 cubes factors that way. This is a difference of 2 cubes, so it follows this pattern. No, this is just for the polynomials. So this is just for this part because it asked me to expand it. Nothing was being multiplied or divided, so I couldn't really expand it, so I had to factor it. Now that I've factored it, I've got 2 things being multiplied together, so I can split it up with addition. So it's log of u minus 2 plus log of u squared plus 2u. And now it's expanded. That's not right. That's not right. Because u minus 2 times u minus 2 times u minus 2 does not equal u cubed minus 8. No, it doesn't. Multiply it out. No, it doesn't. It doesn't. What'd you say if these last two were pluses? These two multiplied together are a difference of 2 squares that give you u squared minus 4 if you pull it out.
Yeah.
Times u plus 2. You're very confident in this that you think this is going to work.
It does. It literally does. For me.
Because u minus 2 to the third does not equal u cubed minus 8. You can only distribute exponents inside if you're multiplying or dividing, never when you add or subtract. What's SOS? Same change plus.
I don't really talk that's like only
What's your question?
I don't understand how you got I don't understand how to get A plus B.
When we some are difference of 2 cubes.
Yeah.
Hold on. Let me search my algebra. We did this in algebra 2. I'll have to run you a copy of the patterns from algebra 2. But this is an algebra 2 pattern. Yes.
Let's get the whole class.
I literally just ran colored copies for algebra 2 like a couple weeks ago. And I know there was some extra. I don't know. I'll run some for you as soon as we finish. Yeah. What? It does that until I fix it. All right, what else on your homework? Here's number 3 and number 4. There's an example of one, and then there's one with the variables on there. You also have the difference of 2 squares first, perfect square trinomial, and then the grouping, which y'all do anyway. But there's your little reference in case you forget that is how we factored this. Yeah. All right, other questions about your homework?
I grabbed the one.
11. A is after you've taken the cubed root.
Oh, we messed these up.
Oh, I got it.
Look.
This is just one side.
Wait, where are they missing?
Oh, it might be. I'm sorry. It's because auto numbering took over in Word whenever I made it 2 in one page.
I didn't get in there.
It's the same thing. It's all the same thing. They're all the same. Some of them say 6 through 10 and some of them say 1 through 5. It's just the auto numbering and it's okay. It's all right. Okay. Number 11, log base 7 of the fourth root of 5w plus 2. This is an expanding one. I don't see anything to do here, but I do have an exponent. Does everybody see the exponent that I have here? 1/4. And since it's an exponent of 1/4, I can rewrite that root that way. I just bring it around front. That's it. That's it. There's nothing else you can do with that. Expanding is definitely harder than condensing. Expanding is harder. What did I say was easier? Did I? I can't even think right now, to be honest, because I'm so hot and so frustrated. What? Yes. 12? I printed a paper, I'm sorry. All right, so I'm going to split the top and the bottom of the fraction first. Natural log of 3r squared minus natural log of r minus 8. Carter, that r minus 8 goes all together with that natural log, right? The squared is only hooked to the r. It's not hooked to the 3r. It's only hooked to the r. So whenever I split up the 3 and the r squared, I'm going to do log of 3 plus log of r squared minus log of r minus 8. And now I can bring that 2 around front. You can leave that open, Noah. It's just so hot in here. Same. It's making my head hurt. Which one? Yeah. What up? How are you? It's hot as crap in here, isn't it? Oh, funny you should ask. The thermostat's broke.
I don't even know that. I don't think it's right.
It is. I'm telling you. He feels like he's a failure.
Well, he said he does like work there.
He's talking about we as educators. He said, as an educator, this is. Yeah.
He did say something. Yeah, I feel like he said that we are draining. Yeah.
Lucy has no ill intent. Come on. Lucy, all right. Huh? That's just some hot. Okay, I'm going to change this to an exponent. Carter. Bro. I'm going to take the 1/2 exponent to everybody. Or I could bring it, actually, I might bring it around front first. I'll probably do that first. Do what? Do it either way? You can, yes. But so if you do this first, you have to remember this 1/2 is going to go to everything when you expand this more. So this is going to be log base 6 of 3 plus log base 6 of m plus log base 6 of n to the 8. And now since I'm expanding, that one goes in front too. But just in front of that one, okay? So it's 1/2 log base 6 of 3 plus log base 6 of m plus 8 log base 6 of n. And if you have that, that's fine too. So if you have 1/2 log base 6 of 3 plus, just make sure that 1/2 is going to everybody. Look, you've been there plenty of times, haven't you? Other questions? $19? Yep. $19? Not a lot of options on there for breaking the thermostat. That's not on there. It's not an option, okay? You have X number of options to choose from, and that's not on there. Okay. If you're in power school, you're an option. Created what? I'm going to split the fraction up first. Log base 2 of the cubed root of x to the 4th y to the 7th minus log base 2 of z. I'm going to change the third root to 1/3. It's 1/3. The root is a fraction. Minus log base 2 of z. Same scenario as before. Split it. Okay, well, different people, I guess, think different things. Students struggle with all things logs, though, honestly. Which is why we're taking some time to go over it, because we did it in Algebra 2, but clearly we needed a little more. Not quite, but almost. What else can I do? That's right. Yes, no, maybe so. Distribute it if you want, but you don't have to.